All right, we're good to go. Yep, we're good to go. Here we go. We're on Pytorch. Becoming Pytorch experts. High-level API is what we're going to look at today. And this is the high-level API for Autograd. That's what we're going to walk through today. Oh, what? Oh, interesting. Ah. What is that about? There's a neat little... There's this symbol right here. Let me zoom in on this. This is very unusual. Well, you can't see it that well. Okay, let's go. What is this right here? What is that symbol? What is that? It's come to something. It's an Asian symbol of sorts. Okay. Let's go back here. All right, high-level API. There's an API in Autograd that gives you direct access to the important differential matrix and vector operations. In particular, it allows you to calculate the Jacobian and Hessian matrices of a particular function for particular inputs. The Hessian is like the Jacobian, however, it expresses all second derivatives. Oh. It also provides methods for taking vector products with these matrices. All right. Let's take the Jacobian up. Hey, how's it going there, Running Gaming? Good to see you. Welcome on in. Happy Tuesday. We're becoming Pytorch experts here. We're looking at the high-level API for Pytorch today. The Jacobian. Let's take the Jacobian. Oh, hey, how's it going there, Dixon Tech? Welcome on in, J Dixon Tech. Welcome on in. Hey, Steven, good to see ya. We're going to evaluate. We're going to use the Jacobian function, high level right here. You can do this right here, Jacobian. EXP adder and inputs. Where's our EXP adder? Oh, okay, so we have an expression adder. So this is very similar. No, this is just weird. This is just a random. This is just there's nothing behind this. It's just a bunch of operations. And then we're going to use Torch, Autograd, Functional, and Jacobian. Right there. Right there. Are you a big Python guy? Yeah, I am. I sure am. We're mostly, though, AI, right? And that's where Python comes in, because a lot of AI is in the Python world. The majority of it, right? Most of AI is in Python world. Due to the simplicity and to be able to express different equations. Like, for example, this right here. It's very difficult to achieve this in other languages. Because what you're seeing here, X is actually a vector or a matrix. And same as Y. However, you can express mathematically those operations using simple symbols like this rather than a whole bunch of list comprehension and for loops. Isn't that a lot better? I think it is. I think it just is so good. I like it. I like it. Hey, what's your favorite Marvel character? Is it Iron Man, maybe? I like Iron Man. That would be my favorite. Probably. Is there a different one, though? Maybe. I don't know. We'll think about it. Me too? Nice. Running Gaming, really? That's great. All right. Here we go. So let's do some coding, guys. Let's do some coding. So we're gonna write this code out, and we're gonna do this so that way we kind of understand what's going on. And then hopefully, this is unusual to hear. Hopefully, we'll make some mistakes. And the reason why I say that is because then we can debug it, and then it helps us memorize things. We want to make mistakes. Hey, Claude, good to see you. Welcome on in. Good to have you here. All right, so this is going to be vim high level.py. This is a high level Autograd. Second is mine, man. Oh, all right. Sounds good. We love you, Claude. Yeah, we sure do. We use Claude all the time, all day, every day. Every single day. All right, import torch. And then we're going to say input equals a very unusual input, by the way, which is odd. You don't usually do this. Print inputs, and then you're going to do a Jacobian on the, oh, very interesting. Let's see what this does. This is not what I was expecting. Torch rand1, torch.rand1. Write that, I think, write that. Odd, right? Because it's a tuple of tensors, right? A tuple of tensors. Very weird that we have a tuple of tensors. I'm not familiar. I'm not used to this. All right, def expression adder. Let's create this function. Def exp adder, I suppose, x comma y, and it's going to return. What was it? It wanted to return 2 times ex.ex, was it x.exp? Times y plus 3. All right, plus 3. Make sure we got everything all nice and tidy there. So y is going to be multiplied by 3, and then this expression is going to be added to this with exp2. Sounds good to me. All right, so now we've got our exp adder, exponent adder. Let's print this out. Print input. Thank you, man. All right, good to hear. Happy to help. Be careful, man. I heard that this AI is killing YouTube channels. So, AI one YouTuber channel, and be careful. Okay, we'll be careful. All right, thank you for the reactions, you guys. Be careful for AI. I'm kind of curious about that. Let's go. Hey, Kyle, let's go. Plum.com. Hey, good to see you, Kyle. Welcome on in. Happy Tuesday. We're going through some high-level Pytorch APIs right now with Autograd. The high-level Autograd API. So this is going to give us, we're going to get into the internals. So we're going to run a Jacobian on this pattern here. X and Y. And I'm not used to this. I'm not used to it, really. I'm not used to it. Hey, Levi. Good to see you. Hi, Stephen. Hope you're doing well. We are doing well. Thanks for saying it. Then bio. Wait. Then H0BO. What is it? What is that? What is that? Hey, you've got Java. You have a Java symbol on your avatar. Your avatar's got a Java symbol. I'm looking at it right now. Right there. It looks like Java. Are you a fan of Java? Are you a programmer? Well, what we're doing right now is we're going through Pytorch. We're becoming Pytorch experts. We're going through the high-level API right now. That's what we're doing. See the video I mentioned? Okay. Well, hey, you know what? If you mentioned that we got to be careful, I'm going to be careful. We'll have to watch that video later. I'm be very careful about it. Okay. Let's print this out. Let's print out the inputs and let's see what we get. Okay. Print high level. No, Python high level. High level. Here we go. All right. Java is pretty goated. Java is everywhere. Let me put it that way. Java has made its way around the world. High level Pytorch API. Got it. Yes, that's what we're doing. You sure got it. The Autograd high level API. All right. So this is going to be a tensor. We're not going to have the same tensor. The numbers are going to be different. So it's a tensor, essentially, what do you call it? A scalar. However, it's also a vector because it's in an array, and it's a tuple. So that's what we should see. Man, save that link and see for the video later. Will do. Will do. So yeah, so we got different values on our tensors because it's random, right? And then we're going to run this. So torch, autograd, functional, Jacobian. All right, torch, autograd, functional, is it Jacobian. And then we do exp add and input. And then we're going to print, oh wait. Oh, no, it's going to return it directly. It's going to return it print. Let's print this. Okay, there we go. All right. Woo. Oh, woo. Okay. All right, there we go. Hey, Levi, how do you manage time, Stephen, when you're a CTO, big firm, and you stream on YouTube too? Yeah, I know, teaching and learning cool stuff. I'm a university student and somehow poor with time management. Well, I wake up really early. So I wake up at 4:30 in the morning. That's part of it. I also prepare all of my meals in the morning for the whole day. So that takes care of a bunch of time. I work from home, right? I've got my home office. That saves some time so I don't have to travel anywhere. So there, gives me a whole bunch of time to do stuff. Also, I only stream for things that I would be doing normally anyway. Right now, we're learning a lot of Pytorch, right? That's the goal. So if I wasn't streaming, I'd be doing this anyway. So I'm already doing something that I'd be doing anyway. Also, by streaming and describing things and having you help me on stream here, I'm learning more. So it's like you're benefiting me, and maybe it's a double win, right? So I'm not really spending any extra time streaming. Does that make sense? Does it make sense? I'm actually doing what I'd be doing normally. So what you could do as well is if you were studying, you could stream studying and then describe what you're doing on stream and then learn it better. Because as you recite things, your memory, how human brains work, when you read data in your mind, it actually writes data at the same time. It's a read-write operation. You can't do anything about it. So if you take advantage of that, you'll be able to learn better because you're read-writing. You're reinforcing your learning. So that's what we're doing. If your friend started a company, got growth, then you will partnership, invest in company related to AI. Claude, wait, what do you mean? If I and my other friend start a company, and got growth. Yeah. So send me a direct message. Send me a DM on Discord. I am an angel investor. I do angel investments. Okay. So let's take a look to see if our code worked. Did it work? It sure did right there. Okay, it did math. That's all I can say. It did math right there. Look, it did math. All right, that's all I could say. Oh, I see. You have really clear mindset. Yes. Nice. Also, wake up early. Sometimes waste a lot of time on YouTube shorts, which are related to non-tech like comedy. Hey, I do that too. Hey, you gotta unwind a little bit, right? You gotta spend time entertaining. I do that. I scroll on the phone. Okay, so we did some Jacobian matrix math, matrix manipulation, which is very odd because I'm not familiar with this process. Essentially, this gives you the ability to write your own operators. I don't see why you'd need to do that though, because it's already on the graph. What does this do? If you look closely, the first output should equal 2e to the x. Since the derivative of e to the x is e to the x, and the second value should be 3. It is 3. Right there, look at that, it's 3. If you can, of course, do this with higher order tensors. Let's increase the order of our tensors. We're gonna increase the order of our tensors. I'm not sure what that means. Man, thank you. I respect and see. All right, sounds good. My friend is just started, so some growth needed after I growth. All right, well, sure, just respect you. Sounds good. Thank you once again. Absolutely, Claude. Yeah, good to have you here. All right, let's just increase. We're just increasing the value of the random. That's all we're doing. Oh, no. We're not increasing the value of random. We're increasing the dimensionality. So instead of a vector of 1 element, we're going to create a vector of 3 elements. So this is essentially a two vectors in 1. Okay. Okay. So, does it have to be a tuple? Very interesting. I'm actually curious about this. Okay. So let's go ahead and I'm going to bump it to 2. I'm going to bump it to 2 and see what happens. We're going to see. Okay. So it's still 3. Let's bump 1 down to 1. Is it going to matter? It doesn't. Okay, good. Okay. So we don't need this, right? We don't need that. Oh, we do. Oh, because of XY. Oh, got it. Because of XY right here. Okay. We're not immune to human psychology, even if we understand it. I know we're our own trap. We're trapped in our own minds. We're gonna think whatever we end up thinking. You gotta meditate. Just turn everything out of your mind. Nothing out of your mind. Just take it out. I know it's hard sometimes. You can distract yourself though. Okay. Let's go to 3. The same thing here. Okay. All right. So we see the same thing, which is very strange. It's very strange. So we see identical on the second output right here. The X and the Y returns. It's interesting. It is interesting. I'm not sure exactly what's going on. However, this is part of the learning process. You don't always get it immediately. Today is a short stream because of your meetings, and I respect and understand that. Yep, you know it. We got 40 minutes. So we're good to go. Hey, James, how's it going? Hey, Steven. I was wondering how feature extraction works with natural language processing. You want to use Pytorch to help determine the quality of written documentation. So there's a couple of approaches. You can train an embedding model to give you vectors, and then you can specify quality and just define quality, what defines quality using the same embeddings, and then calculate how close they are, the input data. All right, so let's do this real quick. Okay, let's go over here. Let's do some drawing, you guys. Let's draw a little bit. Okay, so you've got one document here. You've got a document. And this document is your baseline document, right? This is the document that is quality. So this is your quality, right? This is your high quality, your quality reference, right? Clear your mind, mind, echoes. Got to clear it out. So this is your input document, your reference document, right? And then you're gonna have another document over here that is gonna be an unknown, right? So it could be a bunch of non-good. It could be not good, or it could be really good. And so whatever you're defining as quality, you need a bunch of sample quality references, right? Because different topics and things like that. So you're gonna define quality. And then you can take something like through NLP, right? You can define a vector. So you can either train your own. You can train your own. If you want to train your own, you need a lot more than just the reference document. You need good and bad, right? And then you need to use triple loss and create your own embedding model, your own NLP embedding model. So you could triple loss if you want to do that. Let's see. And then what you do is you're going to vectorize. So say you already have your embedding model. Say you already have it. You're going to run this through a vector embedding, which is going to create a whole bunch of numbers, right? It's going to create some numbers. Say like 0.4, and then 0.98, 1, a whole bunch of numbers. 0.3, 0.5. Let's say. So you'll do that. And then you do the same thing with this other document. And this is done through an embedding, right? So this is your embedding here. Embedding model, which if you pre-trained or if you grabbed some other embedding model off the shelf, you could do that as well. Information architecture, yeah. Then you do the same thing with your other, let's see here, copy paste. So you do the same thing over here. It's going to give you different numbers. 0.7, 0.6, 0.9, 0.1. And these aren't the exact numbers that are being represented here. So you get different numbers, and then you subtract them, essentially. You figure out what the delta is. Or you can see how similar it is. You can do dot products and cosine similarity. And essentially what you do is you're going to take these two, and you're going to subtract them, and it's gonna give you a new number, which is gonna be it's gonna be what you call a scalar, and it's gonna give you a score. It'll give you a score. So let's say a score between 0 and 1. So say you get 0.9, which means that they're very close, or you get 0.1, which means they're not close. So if you get 0.1, that means your document is gonna be low quality based on your reference. If you get 0.9, that means it's really close to your quality document reference, and you're good to go. So embedding model, embed the vectors on both, and then do cosine similarity or some other subtraction if you want to do that, or dot products, things like that. You could do that. That'll do the trick. What you think about India tech startup? Understand every country had a good and bad side, always need to improve. The whole world, it doesn't matter where you are. India is very heavy in tech. It's very heavy in tech. What makes a quality document is hard to question. Yeah, it is. It's really good. You need to have, it's probably like what you reference. What are you trying to reference in quality? That's really what the trick is. It sure is. And that's where your IP is going to come from, right? So if you're going to try to build something like that and you get a good reference quality, you're going to have, your data set is going to be valuable. Do you think if you were using this to try making a PR triage tool, whether to close a PR or merge is a good proxy? Oh, it sure would be. Well, I mean, I think it's a good proxy. Yeah, James, good idea. Thank you very much, Stephen. Okay, got it. Yeah. So if you get the diff, right? You get the diff on the PR and see what the output is, and you compare it with a closed merge or a closed never not merged, right? That would be a good data set. That's a good data set. It's not always perfect because sometimes the quality would actually be really good and it's closed. And it's closed because the the maintainer said, I don't want it, right? Even though it could be really good. They could say they don't want it. Awesome, man. Yeah, you're welcome. What do you think about decision trees? Just learned them today. You know, I've not really ever used a decision tree. It's never been practical for me to use one. So I can't tell you anything other than that. Let me check my time real quick. Are we at our time? Hey, how's it going there, Milan John? Good to see you. Hello, bro. Welcome on in. What's up, bro? We are becoming Pytorch experts. We're going through the high-level API for Autograd. That's what we're doing today. Levi, oh, I see. Nice. Okay. So let's keep going here. 1 second, though. I think I need to take my medicine. 1 second, you guys. I gotta take my medicine. Oh, let me double check. Okay, yeah. 7:30. Okay, perfect. Okay, gotta take my medicine. 1 second. All right, medicine time. 1 second, you guys. We're gonna get back to Pytorch here in a second. Take medicine. Okay. Barcode. Okay. I'm gonna type this in. All right. Big barcode. This is my system for remembering that I took medicine. I type it down. All right. Good to go. You good, bro? We are good. Efron, how's it going? Good to see you. Medicine for what? I hope you are fine. Yes, I had some problems and it hurt a lot, and now we're getting better. I remember seeing your live before hitting 1K subs. Oh yeah, now you got 1.9K subs. Hooray! Yeah, Milan John, we're making our way, aren't we? We're doing good now. Yeah, where are we now? Where are we today? Let's go, Steven. Where are we at right now? Oh, 12.2K. All right, we're making progress. Making progress, yeah. And then the 1.9K that you saw, that's number of videos. A lot of videos. Yeah, we're at 12.2K subs is where we're at. You got it, 12.2K subs, Milan John. How do you have so much energy? I eat healthy. Breakfast, what is breakfast? It is broccoli and seeds and berries and fruit. Carrots. What else did I have? Peas, things like that, you guys. So you eat healthy and you're good to go. And just eat healthy for the whole day. Eat healthy for the day. Let me guess, medicine of improved sleep or some mindful medicine? No, this is a very specific medicine for a specific thing. I feel called out. The Efron. We are good. Yeah. Hey, we'll tell you all the things. I'll tell you all the things, you guys. Yeah, I had emergency that I had to deal with, and there was a lot of it hurt pain. It was a lot. It was very painful. It was really painful, and I made a mistake, and I corrected the mistake. So we're good to go. My alarm's going off, and I have to go check it out. I'm sitting here with cheese and chips and a Red Bull for breakfast. Oh, the Efron, you are being called out. Yeah, eat vegetables and fruit. Nothing processed, nothing ground, just the whole grain, the whole seed, as much as possible. Unless it's a high oxalate thing. And then, and also drink a lot of water, which I was making a mistake on. The music, I know, right? The music. All right, 1 second. I'll be right back. BRB, the music gives you anxiety. Oh, does it? All right, well, we don't want to have you anxious. There you go. How about now? That's probably better. Okay, you guys, I gotta go. The oven, I'm making more broccoli. Hi, do you remember me? Hey, Nike, good to see you. Yeah, 572, Nike. Welcome on in. Happy Tuesday. We are going over the Pytorch Autograd high-level API today. We're using it. My timer's going off. I have to go get the oven. It's a broccoli. Be right back, BRB. Oh, hey, I've just bought a new TV. Oh, Shock Hat, that's great. And now I'm watching you live on the TV. Hey, that's awesome. Hello over there. Hi, I'm on the TV. Good to have you here. That's great to hear. The music was appropriate for a conversation about not dying. It was, again, yes. Absolutely, Nike. Absolutely, yes. Go get your broccoli. All right. Chug the water. You got it. You got it. Chug the water. All right. BRB. All right. We're good to go. All right. Broccoli is in a good spot now. Okay. It was in the oven. Okay, let's get back to it, you guys. Let's get back to it. You can, of course, do this with higher order tensors, which means that you have more numbers. That's all it means. It means more numbers. I'm actually really surprised because they make it sound really fancy, and it's like they just added 2 numbers to each of the arrays. Oh, your real name is Brantley. Did you say Brantley? My real name is Brantley. I don't remember that. I don't, so it doesn't count. I didn't get it. Why are you using Pytorch? Hey, SQ Lighter, good to see you. I hope you're doing okay over there. I heard everything's working out a little bit better, a little quieter for a couple days, and I hope your sister Neva is doing good. SQ Lighter, good to see you. Why are you using Pytorch? Shawcat? Why not? Why not? We're learning it. It's one of the leading industry frameworks for AI and machine learning. Why is my laptop using 100% CPU? Well, you got to check your task manager. You got to check your task manager. Oh, wait, you probably already are if you're seeing your CPU at 100%. Number 1, all right. Neva says hi. All right, good to hear it. Say hi back. Hello, Neva, good to see you. But she can't be in the stream today. Okay, that's fine. That's understandable. Yeah, all right. All right, so the Torch Autograd functional Hessian method works identically, assuming your function is twice differentiable. Wait, twice? Wait, it needs to be twice differentiable and returns a matrix of all second derivatives. Okay. There's also a function to directly compute the vector Jacobian product if you provide the vector. Isn't that what we've been doing? Isn't that what we've been doing? Day to day, you're getting famous. Oh, yep, 1 stream at a time, Shawcat. 1 stream at a time. Thank you for the reactions, guys. See the hundreds over there. Appreciate it. Good to have you here. Do something doubling. All right, so you got to double it up. While data norm. Wait, that sounds like a lot more than doubling. Data. Why data? Wait, what is this y.data business? What is this right here? I've never used it. Why is it called data? Why'd they do it? Hey, James, thank you for saying hi. Good to see you. Man, thank you for my startup. I will sure DM you on Discord. All right, sounds good. Need to leave. All right, see you tomorrow, Claude. Good to have you here. All right, let's keep going, you guys. Let's keep going. So, double something. Y is doubling it. While data norm is less than 1,000, double it again. And then return Y. All right, we're gonna do it. We're gonna do it. It's very odd. I'm not familiar with this scenario. Okay, let's go ahead and close this out. Hide some things there, and then we'll continue onward. Do you know how to see live chat on TV? No, I don't. I assume there's like a config cog wheel icon or some sort. Like a configuration icon that will allow it. Almost have 150 subs, Nike. Nice! You're on your way. Keep going. Keep going. Do you know, SQ Lighter, maybe your CPU working hard for you? That's true. It might be working really hard. It's doing the things that you need it to do. All right. Let's get into the tour. Do something doubling. All right. Def double X. And we're going to say Y equals X times 2. All right. Thank you for the hundreds, you guys. Thank you. Appreciate it. Good to have you here. While y.data.norm less than 1,000, we do Y equals Y times 2. All right. And double it again. Return Y. Is that it? Is that all the things we got to do? Whoa, thank you for the hearts. You see a whole bunch of hearts there. Thank you. I see the floating heart icons there. Appreciate it. Oh, 70% of CPU goes to Microsoft's compatibility. Does it? It's a little bit much there for some Microsoft. Forgot to say that whenever growth will begin at this time, we'll sure to DM you on Discord. All right, sounds good. Sounds good, Claude. Bro, he keeps copying? Bro, who keeps on copying? What do you mean? What is... I mean, Microsoft are annoying. Yeah, they sure are. Thank you for all the reactions, you guys. Good to have you here. Let me see. Yep, return Y. All right. So we're going to do some inputs. Inputs equals torch.rand. 3. So we're only doing 1, right? Because we only got X here. So we only have X. We say print input so we know what our inputs are. Okay. And then we're also going to say print torch.autograd. Autograd.functional.hessian? Is that right? Double, and inputs. Like that. Okay. See if we did it right. Let's see if you spelled Hessian correctly. Those are your reactions, Nike. Thank you, Nike. Appreciate it. Oh, wait. It's 30% now. Oh, good. Switch to Linux, right? Switch to Linux. Linux is the way to go. Meet you tomorrow. Sounds good, Claude. My sister, okay, good. It's not that convenient. Oh, it's not. Oh, Linux. Yeah, that's true. If you're running Microsoft, and you're good to go for things like Steam and whatnot. Hey, bro. Oh, I only see chats on TV. If you want to chat, I have to use the phone. Oh, got it. Okay, yes. Yeah, they do that. You switch to Linux as your daily driver? Nice! Linux is great. You have a single user computer, Omarchy. Hey, Omarchy. All right. Good to go. All right, so did we get it right? Oh, we didn't do it properly here. Oh, we got to do something different. I wanted to use Hessian. I suppose. All right, best stream ever. Hey, Nike, thank you. Appreciate it. A whole bunch of thumbs up there. Appreciate it. Had no problem with stream at all. Stream just works. Good to hear it. All right, good feedback. Things are happening. All right, so it's going to be Autograd. Oh, my gradients. Oh, we got to do something different here. Oh, look at that. All right, so some VJPs. Okay. So are we going to calculate gradients is what we're doing? We're doing some manual gradient calculation. Is that what we're doing? It looks like that's what we're doing. Interesting. Linux is hard to use. It is a little Linux has a learning curve. However, it's still pretty easy. Steam. Oh, Steam. Got it. Okay, yeah. Steam even works on Linux too. All right, you guys. Let's do this. All right, so we get inputs. Let's do my gradients. It's gradients equals. What are we doing? Torch.tensor. And we're going to make up our own tensor. It's going to be a bunch of point ones. 1, 1.0, and a 0.001. Some sort of my own gradient. You open Google and it said open 11 windows in the task manager. That's a lot of windows. Do you clean your broccoli in the salt water? I do a little bit of, I definitely clean the vegetables. And then I bake them a lot. Essentially I steam them. Because I tightly cover it. With large language models, Linux OS, not very hard to use. And Omarchy has a handy little menu that lets you change all the settings. Omarchy is great. You're writing it down? Nice. Okay, so I believe this should run without error. All right, we're good. Now, what we need to do is we got our gradients. We're gonna do something. Torch Autograd functional VJP. This is gonna be double inputs and gradients. V equals gradient. V equals grad. Okay. This should work now. I like how there's also almost no coders in the stream currently. Oh, are there? Yeah. There's a few. I saw someone with Java. Icon. All right. We did that. Now check that out, whatever that was. Okay. So what does this do? The Torch Autograd functional JVP Did we type that right? Wait. This is different. Oh, method. Oh, okay. So there are two different. Oh, there's a whole bunch of them. Oh, look at this, you guys. Look at this. Okay. I was like, wait. We didn't type that. We typed VJP. This one's JVP. Performs the same matrix multiplication as VJP with the operands reversed. Oh, the VHP and HVP methods do the same thing for vector Hessian product. Okay, you're learning Python? Nice. Me too. All right, let's learn together. I'm now learning framework. Excellent. Should I run a video game who makes my laptop go almost 95% CPU? Or GPU, 95. Yes, you should. Why shouldn't you? I mean, why not? You've got it. Play some games. Make your GPU work for you. You're programming TypeScript, C#, C++, Java, Go, Python, and Rust. Hey, the Efron. Those are very good. Very good. Those are all top necessary languages that we use all in the world today. Those are great languages. Because last time it crashed the computer for hours. Oh, did it? Oh. Well, it sounds like you got some hardware problems there. Got some overheating problems. What's TypeScript? It's JavaScript with typing. That's what that is. Bro's GPU. I know. Pray. We'll pray. Exactly. How's it going there, Mark? Good to see you, Mark. Or Markov. Welcome on in. Thank you for clicking the hi button. All right. For more info. Did we finish the ultimate? Wow. Look at that, you guys. This tutorial right here, we just got to the bottom of it. The Pytorch Fundamentals of Autograd. We just got to the bottom of the page. We just did it, you guys. We just did it. We finished. This one was a really long one. This one took like 5 days almost. I think it takes like 5 days, maybe 4 days. You are an L5 platform engineer, often called staff platform engineering. Hey, the Efron. All right. You're up there. You are a senior engineer, software engineer, right? That counts as being senior. L5. You're at the top. Hey, Gun High, it's good to see you. Welcome on back. Finally, again, Steven on his point. Let's go. Yeah, exactly. B2W, C# rules. It's pretty good, right? .NET, I like it. That is your opinion. VB, then .NET. Python is great too. Those are great. I like those, yeah. Do you have any video about Django, the ORM framework for Python, object relational model, that has a whole bunch of like built-in nice templating engines and other things that you'd use to run on your server to pass over to the client? I don't think I have any Django. I might have one, maybe. I'm not sure. Kerbal Space Program. Yeah, I played that. It's crazy how that game has lasted throughout the ages, right? There's only a few games like that. You know, you've got Minecraft, KSP, and just a few others. And they're old games. They've been around for a long time, but I still see them on social media and stuff. Is Django ORM only though? It's more than an ORM, right? Can be used for creating web apps with HTML and CSS too. Yeah. Usually you're going to use Django if you're going to interact with some sort of database. And you're going to take that data and you're going to have a model view controller. You're going to convert that data into a view. And so converting it to a view, you're going to use Django's templates and Django's ORM. So it makes it easier to do that full end-to-end. So you're going to have a database with a bunch of data. You're going to process that in Django. And then you're going to create a view layer that will render a template that returns data back to the browser. Could be a JSON template or HTML template. You never know. Yes, staff is one step above. Oh, it is. Okay, so staff, got it. It's one step above it. And principal engineering in the Fang A. Fang adjacent. Oh, got it. Fang adjacent. Yes, staff is one step over senior. All right, so the Efron, you're at the top of the world from engineering perspective. You've been through it many years, decades. You have to do decades to get to that level, right? Only use Fast API and Flask. Thanks for clarifying. Oh, those are good too. I use that. That's usually what I use. I usually go Fast API. That's what I do. The Efron. Yeah. We did it, you guys. We did it. All right. So now we're on to a new phase here. Building models with Pytorch, which we've done many times. We've done this many times. I'm going to walk through this really quick to see what we're looking through here. To see what we're looking at here. Maybe we can get started on this. I think that would be... Oh, even convolutions. Okay. So yeah, let's go through this again. I think this will be good to go through again. And it's going through the same path as before. Okay. Sounds good. Yeah, I've been doing it for more than 20 years. Nice. Yeah. Hey, the Efron, we've been going through this together. Oh, 20 years. Yep. More than 20 years. We're doing it. Yeah, I'm in my 40s, the Efron. We've been doing this for a long time. When you're talking, the captions is provided by YouTube. The captions is some open source tech that I've written many years ago. 8 years ago, open sourced. You can use this on YouTube for subtitles, right? It's an open source repository. Hello, welcome. Lots of interest. And it's really easy to install. Really? How? Yeah, really. Exactly. It's something he coded himself. It sure is. You got it. Here, I'll put it on Discord. Here you go. I'll throw this on Discord on our link share channel. There we go. So you can take a look. And it works in Zoom. It works in... So it's like an OBS overlay right here. So you can see there's an OBS overlay. Oh, so call it a... What do you call it? A screen. No, a browser. Subtitles. Here we go. So I can turn them off on right here. Yeah. So it's a layer. There you go. Discord link. Yeah, exactly. Efron. Absolutely. 1 second. Let me get that for you. Over here. Copy. Let me say at the Efron. There you go. Discord link just for you. Here we go. Yeah. And I put it so that way there's only one word at a time. So you can see here. One word at a time. Boop. So here, center text and show a single word. So this is what I use right here. This is the setting I use. The Efron, nice, thank you. Will be good to have you join there in the Discord. All right, you guys, we got around 12, 15 minutes. We got around 15 minutes here. So let's pop back in. Let's start the next tutorial, building models. And then we're going to go to tensor board support, which looks like some sort of GUI. Then we'll go to training models, which is the optimizing, and then model understanding. And then we'll see where it takes us from there. And maybe at that point, we will have more than enough knowledge to start building our own models. I want to build a large language model. I want to build from scratch, right? Or with Pytorch. Maybe we'll use transformers, the transformer, built-in transformer, or we'll write our own. We might write our own. Wouldn't that be great? We could write our own. I've done it once before. I've done one transformer in my life. And I think I want to do another one. And especially with Autograd, it makes it a lot easier. What is using the real-time transcription? It's called NPM Spoken. It's called NPM Spoken. Right here. And you can NPM install Spoken. And also, I wonder who wrote that library. Hey, look at that. Right there. I wonder who that is. So NPM install Spoken, and it lets you do speech to text and text to speech. Hey, Steven, did you hear about Claude code leak and the supply chain attack from NPM? I've heard of... Is there another supply chain attack? I heard about the... What was it? The really big 10 trillion parameter Claude model. What was it called? Morpheus? No. Meh. So what is that model leak called? Well, you write self-attention by yourself. Yeah, self-attention is actually pretty easy. I think it's pretty straightforward. I've done the self-attention before. It's actually not that hard. It's pretty straightforward. You join the Discord? Hey, nice. Hey, Esky, really? All right. Hey, all right. We got him in, you guys. We got him in. Welcome on in. Good to have you here. Thank you for joining on the Discord there. All right, we're good. Things are good. So yeah, so this is this spoken library. So you can do text to speech and speech to text in both directions. Oh yeah. Here we go. And then you can have a little robot there that gives you, you don't like math running gaming? I know, right? Oh, not my main account, by the way. Okay, got it. I was wondering. Hey, all right. Let's see the wave, but where's the wave at? Here we go. There's the wave. Good to have you here. Welcome on in, you guys. Socket Y. Socket Y? What do you mean? Why what? Okay, let's go back over to our Pytorch now. So we're gonna do some building models. This one's easy. We did this one like 10 times already. I think repetition is important though. Let's see if we can make more mistakes. So if we make more mistakes, we can remember more things. All right. So we're not actually gonna watch the video. We're skipping all the videos. We're just going straight into the tutorials. All right. So let's get started here. Wait, Neva is a mod in the Discord. Yeah, you got it. Yeah, Neva's been on this channel for a long time. Has been on this YouTube channel for a long time. All right. So let's get to this. In this video, we'll be discussing some of the tools Pytorch makes available for building deep learning networks. The Autograd, except for parameter. What do you mean? The class we discuss in the video are all subclasses of the module. This is the Pytorch base class meant to encapsulate behaviors specific to Pytorch modules and their components. One important behavior of the module is registering parameters. If a particular module subclass has learning weights, these weights are expressed as instances of parameter. Oh, all right, so this is more information. The parameter class is a subclass of a tensor. Is it a special behavior that when they are assigned as attributes of a module, they're added to the list of that module's parameters? These parameters may be accessed through the parameters method on the module class. So then we can use that when we're initializing our optimizer, so we can pass in the parameters to the optimizer so the optimizer knows what to optimize. Hey Jinlu, good to see you. Welcome on in. How long you're on YouTube? About, well, we've only been really streaming since last November. So not that long. However, we've had our YouTube account for quite a while. Let's see, where is it at here? Look that. Let's zoom out here. So is there like a date here? Joined 2011. There you go. There's the date, 2011. This is making me want to work on my RISC-V assembler and emulator for Kerbal Space Program for KSP, really? Or is that, did you say, is that the same KSP? There could be other acronyms. Maybe you should stream on Word. Yes, you should, absolutely. I recommend it. Because it's a lot more fun. I think it's a lot more fun. It's a lot more fun. Okay, you guys, let's pop back over to tutorial. Check link share, by the way. All right, Jinlu. Link share. Link share. Ooh, oh, you got a new song? Oh, you got a new song. All right, let's listen. 5-minute song. Nice. Yep, Kerbal. Nice. Very nice, Kerbal. Your channel older than my age. Really? Well, I'm in my 40s, so we've been around for a while. Nice, Jinlu. Thank you. All right, this is our song now. These parameters may be accessed through the parameters method of the module class. As a simple example, here's a very simple model with 2 linear layers and an activation function. We'll create an instance of it and ask it to report on its parameters. We're gonna get our parameters from the model. All right, I know what this is. I've done this before. I wanna walk through it. All right, super tiny model, torch NN module. All right, let's do this. We'll probably restart this tomorrow. We'll create a new one tomorrow. We'll just do a little bit right now because we've got some time left. All right, so let's do the vim parameters.py. All right, import torch. All right, class tiny. We're just gonna call it tiny. Torch.nn.module def init self. Super tiny. And was it, let's see, what do we need here? Self init. Okay, self. Hey, Jinlu, I like this. Ooh, this is good. This is a good song. You do good on these songs. All right, so we're going to self-linear. So all of these, oh, this is so cool. Okay, this is one good reason to take this approach because it's automatically going to enable gradients on these. Look at that. It's automatically going to enable gradients. Isn't that great? Auto gradient enablement. By the way, you put RISC V emulator and assembler. You working on Linkshare? All right, Efron, we got to check it out. We're going to check it out. All right. Let's take a look. Kerbal Operation Runtime Engine. Visit the site. All right. And I'm going to click the star button there. Okay. Let's take a look. Kerbal Operation Runtime Engine. Caro. Hey, Caro! We got frogs in here. Thanks. I tried something new with the bass on this one. Ooh, nice. It's really good. It's really good. Oh, he actually works on that. It looks like it, right? Yeah, that's Efron. Right there is Efron, you guys. Let's zoom in. Let's zoom in. Okay. All right, Caro is designed to be an entire rocketry architecture platform. This is the goal, to make a platform that will not only avoid lock-in, only being able to be in KSP, and also provides a way for users to play and or learn any level of computing, from high-level programming to virtual machine code to direct assembly or even binary machine code if desired. Wow. It does not work at the moment. Oh, okay. However, if you want working thing, FlowHS works some before you redid it in the C++. Okay, got it. CPU emulation, RISC assembly parser, comprehensive test suite, cross-platform Windows and Linux support. Future features. FlowH is in the links. Flow. Oh, you added FlowH. Okay, got it. Click the star button. Flow-based hardware simulator. Flow-based hardware simulator. Chip names independent from file. Chips load and save. Brute force chip tester. And title bar reflects the state of the file and the current chip name. Okay, I'm actually curious. What is this? I'm trying to see. Let's zoom in a bit. Oh, you've got gates, NAND, and or NAND or XOR and XNOR. Bit. Okay, input. So you've got logic gates. Recent files. What is this? Okay. It's logic simulation. The main branch should be working. Nice. All right, so we got some logic simulation here. And it is in .NET, C#. Wait, what is this? It looks like C# VS Code. C#? Probably C#, right? I'm guessing. It is C#, yes. Okay. C#, you guys. And you can run it. You can make build. You can test it. Clean. Got a nice make there. Building on Windows. Does it build on Linux as well? You need a bail. Oh, for an interview though. Oh, it sounds good, Efron. Good luck on the interview. All right, you guys. That was a lot of fun. I do want to keep going. Here. Though we do have some early meetings that we got to get to today. So, hey, Ben Pete, good to see you. Welcome on in. Happy Tuesday. Tomorrow the plan is, you guys, we'll start over again on this. We'll start from scratch. We're going to be building a model with Pytorch. We're going to be accessing the parameters directly, I believe, for parameters. So this is the plan for tomorrow. The linear parameters and the tiny model parameters. So you can get the independent layer parameters, and you can get all the parameters in the entire model, which is really powerful. I like that. Okay. So other than, this extra, this part right here is just it's just a bit much. I would like it if there was like a nicer way to express this, because it's just a lot of, I like code that's clean. And this is, it's following the language standard, and it does what it needs to do. I just want this part and this part only, right? This is like internals of the code, and I don't want to have to deal with it. It's fine because it's only 2 lines. It's not a big deal. I just don't want to have to deal with it. Because it's just like, it's like useless. It's not helpful to me to have that there. Okay, guys. All right. Had a lot of fun today. We will be doing more Pytorch tomorrow. That's the plan. We will be doing this part of the Pytorch, which is basically the very simple part of it. I would say the introductory part, the input, the initial front door of building AI with Pytorch. The easy part, the whole framework itself, really. All right, you guys, had a lot of fun. We're headed out now. Thank you for the party popper. We'll see you tomorrow. We'll be back. Enjoyed spending time with you today. More Pytorch tomorrow. We're becoming Pytorch experts. We're going through every Pytorch tutorial is the plan. All right, guys. See you tomorrow. Have a good one. Thank you for the hearts. See you guys. Bye. It's Arc Steven's Arc. You got it, Jinlu. You got it. Good song, Jinlu. Good song. Good to have you here. All right. Ben P, Efron, Jinlu, SQ Lighter. Good to see you guys. See you tomorrow. Have a good one. Bye for now.